Hello, and welcome to episode 120 in this series where I'm programming an NES game from scratch. Let's get started with a quick couple of announcements. The first is that next week I will not be posting any regular programming videos. I may be posting a video in the Zero Page series, maybe, hopefully, related to backgrounds for to continue on with the theme of what I've done in the other Zero Page episodes. So I'll let you know on Thursday if that's looking like a reality. But that'll be the only video for next week. And speaking of Thursday, on the live stream on Thursday, we'll be having Jonathan from Oleschool Gamers, which is a channel on YouTube. I'll link to that below in the description. I tweeted about this yesterday on the 29th about this. He'll be on with me on the stream on Thursday at 9 p.m. and we'll be talking about NES development and his challenges starting on a game. It's going to be very sort of free form, so if you have questions or you want to ask questions, feel free to hop in and ask those questions and join in the conversation. I have the new sort of streaming layout here, so come on, you're going to switch. Oops, no, wrong button. I've got this new layout here that you'll be able to see your chat appear in the right side of the window, sort of to the right here. So yeah, feel free to come by and ask questions, and we'll try to answer them. And yeah, I think it'll be a fun time kind of going over the challenges he's had and what it's like from his perspective getting started at NES programming. So I thought it'd be neat to, since I featured other homebrewers who have completed games, feature some other homebrewers who are starting on games and whatever challenges they have. So anyway, let's get back to where we were here. So last time we got the sprite export working properly with some ugly code that, as I mentioned in the stream, wouldn't be acceptable for if we were exporting a large number of a large amount of data, but because we were working in a guaranteed small set of data, I figured it would be okay for what we're doing. It's not really hindering performance in that particular area. Wouldn't be something I would code, that kind of embedded loop, if it were performance critical. But anyway, so then we implemented this enemy, put it on the map. I've changed the map around a little bit since last time just to save some time on the recording. So we've got this longer map and the enemies appear here. There are a few things that changing that uncovered. So the first is, or adding these enemies uncovered. So the first is that if we launch this with the new map loaded, what we'll see is when we get to the first set of enemies from the map, things will look fine. But what we're going to see is that after the second set appear, we're going to be missing sprites, what's causing that is not only that we have too many sprites per scan line, but we are also we have too many sprites in general because there are only 64 8x8 sprites. So you can see that if I do anything, and in fact here the ship is gone and we've got all the rest of the sprites populated with these bad guy sprites and then the animation. So we're running into a situation where we've run out of sprite locations. So there are a couple of things we need to do. The first is we want to try and re-implement that flicker functionality, so that we actually can see all of the sprites even if we have more than the 8 per scan line. So let's start there. The second thing we want to do, I think, depending on how long it takes us to do this, is we want to update the export tool to look at the map and probably warn us that we may run out of sprites. I don't think we want it to stop anything, but I think we want to have it potentially look at an area and tell us, wait, there are, so there are, I think I counted before, let's see, 6, 9, 12, 15. There are 15 sprites here, and each of them has four hardware sprites, or 15 objects with 4 hardware sprites. So if you zoom in, it's 4 because it's a 2 by 2 tile, right? It's 16 by 16. So that's 60 hardware sprites that are needed to just represent just that. So now if you start, shooting at them, or even just including the player ship, that's already 64 for the player ship to be included with all of them on the screen at the same time. And then we have the other additional problem. If you start shooting at them, you run out of sprites too. So we need to be able to handle that. We need to make sure that our code is not overflowing the sprite memory, which it may very well be in the draw entities here, because I don't think it's checking to see if we've overflowed. I think it's going through and checking all the entities and drawing regardless of what the value of y is, but we should be checking y against 64 and stopping. And if we implement the sprite flicker, the additional benefit of doing that is that we should still see the pieces of sprites that couldn't be drawn because we ran out of sprites. But at the same point, we want to just make sure that in doing that we don't sorry, I'm like thinking how to describe this and code it at the same time. My brain is having a bus conflict. Yeah, so we need to make sure that we're implementing the flicker so that the sprites all appear at some point to make sure we're not losing something. As a result of the sprite flicker, that should help us in the case where we have too many. We need too many hardware sprites, more than what are actually available. So if we need, for example, if we would need 100 hardware sprites to render this, we would still have to stop at 64. But the fact that we're rotating the number, rotating through the sprites here in the PPU, so instead of always drawing the ship here at sprite 0, what we should see is what we were seeing before, which is this sprite will start to rotate through the table, in order to ensure we get that flicker effect. But we also want to make sure that while we're doing all of that, the memory that we're writing to for our sprite mem here, the OAM memory, is not being, we're not getting a buffer out of bounds problem, because there's only so much memory that we've allocated for sprite memory, and if we go past that, we may run into problems where we are corrupting other memory that comes after it. And I believe, let's see, our sprite memory, let's look at where we're clearing our memory out. So our sprite memory for the DMA copy is at 4,000. So we want to make sure, I'm sorry, at 400. we want to make sure that we don't go past the 255 bytes that are available here. And if there are 64 sprites, and was it, it's 4 bytes, so it's 128. So there's exactly enough room for the 64 sprites in here. And if we go beyond that, we're going to go into this 500 range, which would be a problem if we have any sort of data in that range. So let's not do that. Okay, so let's start with just the flicker functionality, because we did have that working at one point, but we had to break it when we were changing over to using our object and projectile lists separately. So let's see. Where are we doing that? So this is the DMA copy of the sprites, but that's the actual. We are actually handling the population of the memory and the sprites through draw entities earlier. We're doing that in the actual main game loop, so that we have more time to populate it. By the time we get to updating that memory, the DMA copy should have already occurred and the screen should have already drawn, and now we're waiting for, or it's in the process of being drawn, and we're waiting for the screen to draw and the NMI to execute and complete, and then we repopulate the OAM via the DMA copy once again. So let's look at what we're doing here. So we have an entity counter and an entity start. That's what we were using before. Do these still exist? They do. So this was initializing the counter. That's fine. This is loading the entity start, and then 248 multiplying by 8. Why by 8? And then transferring and adding. Why is it doing that? Load A with entity start. Sorry, it's been a little while since I've looked at this, so I don't remember exactly how or why this works the way it does. So let's load A, entity counter 0. So that's 0 is that, and 0's 0 and 4 to the sprite mem. Do we even need to do that? Oh yeah, we do, because we're initializing that. Yep, and then y is 0, x is 0, and then we go into draw entities. And then draw entities, x is the entity type, or sorry, the entity offset, and y is the offset into the sprite mem. So what we want to do, sort of at its core, the most basic thing we want to do is we want the y value to cycle around, right? We want, I've explained this before, but what we're saying is we want every time we copy, if the object was here the first time, the next time it'll be in the next spot, and the next time it'll be in the next spot, and then the next spot. We don't want to change how it's organized in our memory layout in the entity list. We want to change how it ends up in the hardware sprites, though. So let's load y with that instead of 0. And then at its simplest, what we can do is when we're done, we want to load A with entity start. We want to clear our carry, add 4, and then store that. So basically, at its core, the most basic implementation of this, I think, unless I'm missing something from how this works, but the most basic implementation of this would be that the entity start position would always get incremented by 4 every loop. 4 because it's 4 bytes each time, 1 for each object. And then the nice thing is, because it's only 8 bits, when we get to the last one in memory, we would loop around back to 0 for that entity, that next entity, and as long as we don't exceed our total hardware entity count, our hardware sprite count of 64, we don't have any problem. So that that seems too easy, but at the same point, I don't remember enough about how this was changed or made to know that it's not correct. It looks like it's actually right. Let's take a look at this. So you can see that it's cycling through every cycle. Now we're still running into the problem of that we have too many objects. So let's take the number of objects down, but let's add more objects per line so that we guarantee that we're going to get flicker. And this is just totally me kind of randomly placing things. So let's take a look at the PPU viewer. We should see that same shifting around. Wait, what happened? That's weird. What happened? Oh, because, okay, right. So I modified it here in draw entities, but that got rebuilt when we exported our code, so we'll have to fix that. But load A, clear carry, add carry for store A entity start. Thought that seemed strange. Try that again. Refresh. Okay. Cool. So now we're seeing it rotate through the hardware sprites. That's looking pretty much like what I expected. I mean, I guess the question... Let me let me do something here. I'm wondering about this method only because I'm trying to think about would it be changing it enough? Let me also make sure I didn't turn off the... Okay, so if you watch this, that removes that problem because it turns off the scan line limit, but wanted to make sure that that was off because that's not how it would actually look on a real NES. I guess I'll have to look and see what that looks like, because I guess the problem is that it's not changing the order enough potentially to where, I mean, it's still drawing things in the same sequential order, which I guess wouldn't have much of an impact on the sprites that should or shouldn't appear. I'm wondering if we should do something where it's not by 4, but instead it's a larger jump. Or, or you know what? The other thing we could do, I think what we did, now that I'm thinking about this, I think that I made this change last time because it was a simple change to make, and then I realized the same problem. I'd have to go back and look, but I think I made the same change last time, and the problem was that, like, now it's still only sometimes having the flicker effect that I want. And what I should be doing is changing the draw order, not the hardware sprite order. I mean, and you could do, like, changing that shouldn't matter functionally. Like, it's just going to make it jump, run through the hardware sprites faster, but I don't think that that's going to actually solve anything for this problem. Or it might make it a little bit less apparent that there is a problem, but still, yeah, it's still happening where part of the ship is disappearing here, and it's because we're not changing the draw order, we're just changing which physical sprite it exists in. Okay, so that kind of makes sense then why that wouldn't work. So instead what we would want to do, and I think that's why it went this way instead, was the point was to that the way it would work is it wasn't incrementing, it wasn't starting from a different point on the hardware sprite side, but rather on the list of objects. So if we look at the code that was here, well, I'm still Still not sure I remember exactly why it was doing it this way. Or if it's even right anymore, given that we're using 2 lists instead of just 1. But what we can do is we could say, okay, entity start here, right? So we want to start with a different entity each time, but then we need to make sure that in our drawing code that we are not exceeding the max entities, and also this makes sense. So sorry, I'm like looking at this code and thinking about how all of this works. So where does this increment the X? Register. Transfer X to A. Clear carry, add carry, size of entity, transfer A to X, and compare X to total entities. Oh, because it's the size of entity, right. That, let's see, total. So total entities is kind of a misnomer. This is more of like upper bound of entities, right? And I say upper bound, meaning like upper bound of the memory buffer. Okay, so all right, so we'll have to fix all of those. And that code gets generated also, so we'll have to fix that as well. Okay, so let's save that. Didn't save the main source file here. All right, so all right, so let's see. So nothing actually changed. We just stopped it from doing that whole hardware rotation thing. So let's take a look at now. So we have check and sprite. I believe this is doing So this is actually doing exactly what I wanted, which is it's incrementing x and then determining if we've reached the upper bound of the buffer, and if we have, it's resetting it to 0. And then we're incrementing the entity counter to determine if we should continue, because it's going based on the number of entities, not based on the upper bound of the memory. So the next part that we need to address here is probably relatively straightforward, since that's still there, which is, so we're loading x with entity start, but this is why we're doing this multiplication, because it's based on the size of the entity structure. So the entity structure is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's 9. It's not a power of 2. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's okay. Okay. Now I'm understanding why it's doing this crazy nonsense. So what it was doing, which isn't actually such crazy nonsense, is we were doing our times 9. So we were loading entity start, and then we were shifting left 3 times. So what we want to do is entity start times 9 via entity start shifted 3 plus entity start. Right, because let's put that in square brackets so maybe it's a little bit clearer. So what we're doing is we're multiplying by 8 and then adding 1, which is effectively the same thing as multiplying by 9. So that's why we're doing this ASL 3 times, and then clear carry, add carry, entity start, and then transfer A to X, and that would be that. So we don't need this anymore. I don't think we need any of that anymore. Except for except for when we deal with incrementing entity start itself. So we do that here. Let's do that now. Entity start, right? Instead of doing that here, once we're done with the sprites, let's increment entity start and then compare, load entity start compare to max entities, and branch not equal to there, otherwise load A with 0, store it into entity start. If we wanted to be real clever, what is max entities? It's not a power of 2, right? 1C is not a power of 2. No, of course it's not. If we had made it a power of 2, we could have used our little AND trick for the modulo, but that's all right. So let's see how we're doing here. Nope, that is not the word make. So let's see what we've got here. That doesn't seem to be doing anything, so let's take a look at what's going on. Transfer A to X. I can tell you, I think... Alright, so the only other thing is here that we have this problem of this is not doing the same logic here, which it should. Well, yeah. So this should be doing the same thing here, which is loading entity start and doing the same calculation again. Probably store that off somewhere so that we don't have to recalculate it. And then we have to reset the entity counter. And then, let's see. That's probably why this is not working the way I expected, because for objects, it was effectively doing the same thing as before because it was getting reset to 0. Except it does not appear to be doing anything different. Why? Load, entity start, shift, clear, add, transfer, load A, store A, entity counter, transfer A to X. Let's take a look at some memory. So A7 is the address in question. And we just want to see what it is doing every cycle. It is doing something, so that's good. Better than what I was thinking. Well, that's interesting. It does seem to be... Maybe it is... I guess it is swapping stuff around, but because of the lack of variety in the data, it's once again not... But you'd think that would, with the enemies in the list, you'd have enough sort of data to make it do enough objects in memory to do what I was hoping. Let's slow this bad boy down. All right, so it is random. It is reshuffling stuff, but the problem is that because it's reshuffling, with the empty entities. It's not swapping every time. So what we're seeing is, to explain that a little bit more clearly, because, for example, when you start the game, if you have your script running, you will see that there is this object always in the list here, and that object always in the list there. And all of the rest of them are 0. What's happening is, let's talk about the first run through. It draws the player and then the cloud into the sprite memory, and then nothing, because everything else is entity type 0, right? Next time around, it draws the cloud, nothing, and then the player, and then entity type 0. And then all the rest of the runs through because entity type is 0 across the board all the way to the end, it's doing the player and then the cloud consistently over and over again until it gets back to the beginning of the list, at which point it does the player and the cloud, and then it swaps the order finally. So what we really need to do is not only be shuffling where we're starting, but we also have to take into account whether or not the entity that we're starting with how would we do that? I mean, it would be probably not that difficult to write the code to do it, but it seems wasteful, because what we would need to do is we would need to say start here and draw, start here and draw, start here, but because there's nothing here, actually go back to here. So essentially what we're saying is we want it to skip starting at these entities because they are empty. We could do that based on this is further complicated by the fact that the objects and entities are split up. Sorry, the objects and the projectiles are split up because or is it? If we were to say, okay, every time we hit an entity that is type 0 in the list, increment the entity start back to until, well, then we have a different problem, which is that we will hit the end of the list and force ourselves to have to go back to the beginning in order to reset potentially to an object that exists in the list. And if the other issue is if the objects list is sparse, let's say I do something like this where I fire one bullet that's a little bit closer to the top than another, we're going to get a gap in the list. So that idea of looping till we get to the beginning is no good. The same thing would happen with entities. If you have an entity that spawns and despawns faster than the next object, you'd have the same behavior where you get a gap in the list. How would we handle this? What's the right way? I mean, the easiest thing I can think of is that you check the type at the entity start, and if you even that only works on the object list. You'd have to do that both separately on the object list and the projectile list. So if you said, okay, my entity start is a type 0, I'm going to increment until the point that I get to something that is not a type 0. And you run out of entities. I mean, that's what we're doing right now. Maybe we need two different entity starts. We need projectile entity start and object entity start. Because what I'm thinking is that what we'll do is when we see that the if we check the entity type, right? So if it's, in this case, if it's a projectile, that's a bullet or an enemy bullet, it'll process, but otherwise it'll skip that and increment the entity start position Well, but that doesn't actually solve the problem, because what I wanted to do is take the entity start and increment it to the next viable object that isn't a type 0. Sorry, I really hadn't thought this part through. The other thing, the other possibility of what we could do is you could do something where you alternate the direction you traverse the list for updating the hardware sprites. Not crazy about that. I guess what we would need to do, it's kind of weird. I don't know why I didn't think about this before, when we were, or why this wasn't an issue before when we were dealing with this. But basically what we would need to do here is we'd increment the entity start, load it, we'd increment the entity start, and even that we'd have to do, like I said, two different things. We'd have to have an object entity start. Realistically, we'd probably want to have two different, an object and a projectile entity start. But let's say we're doing just the objects here. We'd increment the entity start, then check the entity type until we got something, either until we got something that was not a no entity type, or until we ran out of entities to check. But I think what we can do that's a little bit smarter. Yeah, what we can do that's a little bit smarter is we can keep track of it. So what I mean by that is let's just do it for objects first, and then we'll add the projectiles. So since that's what I'm kind of looking at here, so this is our part where we're dealing with drawing the objects. So what we need to do is we need to if we get some type that is not no entity, and x is not equal to the offset for the I don't even know if we have to do it that way. Let's do this. Load a temp1. No. Load store y into temp1. Oh, actually, what am I talking about? We have an entity counter. We don't even need to do that. We have the entity counter that we're using already. So basically what we would need to do is we need to go here and we need to say, okay, so do I want to do it after the item is processed or after the item, after this is incremented. I think after this is incremented. So load A, we're already doing that here. So branch if equal, meaning it's 0 to here. Like, we don't need to do anything if it's 0, but if it's not 0, load A, where are you? Oh man, where is that? I need the beginning. Objects, entity type X. So we're going to load, no, not the X position, X. And then branch if compare to entities no entity, right? That's the entity type. Branch if equal to here. So like if it's equal, we're just going to skip over this part. Otherwise, what we're going to do is we're going to store. Now what we're going to do is we're going to take the value of X and divide it by 9 to find out what this index is, and then store that into entity start, because that's going to be, oh, except we don't want to do that. We want to do, we actually do want to compare it to 1, because we only need to do it the first time. So if this is the first time that we're looping through here, and the no, actually I'm wrong, I'm sorry. We want to do it for any non-zero entity count, provided we haven't done it already. So we can use temp1 for that purpose, right? We can like increment temp1. We can even load a temp1 branch if not equal to this guy here. So if temp1 hasn't been modified, to be 1, then we're going to branch it, or if it has been modified to be 1, then we're going to branch to here. Otherwise, we're going to load the entity counter. If it's 0, that means this is the first time we're going through, so there's no point in checking, because we know that the entity type, no matter what it is, shouldn't matter, because we want to go to at least the next one in the list. And then we're going to increment, no, we're not going to do that yet. We're going to load the type, and then we're going to compare it to no entity, and if it's equal, we're going to skip. Otherwise, we're going to increment temp1, and then we're going to do the divide. So like I said, so what we'll do is we will, we have transfer X to A, and then bear with me, because this should work, but I don't remember if it will in the way exactly I'm thinking it will. So 81, okay, so that's 81 in decimal, and then what we should be able to do is it's not ASR, what is it? It's 652 opcodes. There's rotate right, but that's not what I want. Or I guess it doesn't. Well, no, it doesn't matter. ASL. Arrow function left. LSR. That's what I'm looking for. LSR. I don't know why I did ASR. So, oops. So assemble and run that. And that gives us 10. And then logical shift clear carry, subtract carry, and the value. Divide by 9. Actually, so we should, I think, actually do this. Clear carry, subtract carry 9, and then do our shifts to divide by 8. Assemble, run, and that gives us 8, which is 1 less. Which makes sense because we're subtracting the 1 and then doing the shift by 8. So, so that'll give us our index less 1. Clear carry. Transfer X to A. Clear carry subtract 9. Or, well, this doesn't work if we change the entity size, so and then we do our shifts right. I just keep feeling like, let's see, if we do this, we get a value of 10, which is not right because we want to do 9 times 9, or 81 divided by 9. But that is the result minus 1. Is that just a coincidence? Nine times 3 is 36. No, it looks like, so we could do clear carry, subtract 1. That's our index, so store that into entity start. So that's where the objects should start next, and then we should be. So let's document this because I'm not going to remember this because it's kind of crazy. Check temp1 to see if it's 0, because if it's non-zero, we've already determined our next entity start. Get the entity counter to see if it's 0, because if it is, we haven't. Well, it should never be 0 actually, because we'll have always incremented it by 1. So this is a useless check. This is why it's useful to document this stuff sometimes. So load the entity type to make sure it's not an empty entity. If it's empty, then wait until the next loop. If it's a non-empty entity, then increment temp1, so we don't do this again. Divide. Sorry, I was just checking to make sure A actually had the value. Oh, that's on the transfer. divide x by 9 via x shifted by 3 minus 1. Let's see, does that make sense? I'm still not 100% convinced that that's right. So 81 divided by 8. Well, so partially it's because we're using, so if we do 81 divided by 8, we get 10.125. Right, and then when you truncate it, you get, that's 10, and then you minus 1. Yeah, let's go back to programmer for a second. So 81 divided by 8 gets 10, minus 1 is 9. Let's try by itself. So 9 divided by 8 is 1 minus 1. Yeah, that doesn't work because it's probably, so 18 divided by 8 is 2, minus 1 is 1. That's not correct. So it only works for values that are larger. Because what it should be is 18 minus 9 divided by 8, which would give you, well, that's not right either. What am I talking about? So 18 minus 8, wait, I'm dividing by 9. 18 minus 9 divided by 8 gives you 1. That's right. So 36 minus 9 divided by 8 gives you 3. But that's not right. That should be 4, right? 27 minus 9 divided by 8 gives you 2. I mean, if I wanted to do, is my other math wrong? That seems correct. So 3 times 8 plus 9, 3 times 8, right, plus 9. No. Right, okay, sorry. So my brain is conflating two things. So it's 9. Sorry, it should be 9 times if the structure is 9 bytes, and I want to find out what the index in is for the 4th element, which we know is 36, because 9 times 4 is 36, right? The index is the thing that changes. The size of the array of the struct does not. So it's 4 times 8 plus 4. So it's plus the index size. If we did right, because it's 9 times that, not 9 times 9. So bear with me because I'm, so is my math wrong here? No, my math is right here. I'm shifting it times 8 and then adding the entity start to itself after it's been multiplied. So in the opposite case, if we have 81, for example, which is the 9th element, we want to divide by, we want 81, we want to subtract. Yeah, don't we want to subtract? I mean, that works, but it doesn't. If you do 18 minus 2, for example, then divide by 8, you get 2, which is the reverse. That doesn't help if you don't know the index, though. I don't think I've tried to do the decomposition of... Usually anytime I'm doing this, I'm doing multiplication. I don't think I've actually thought this part through. So what we're saying is, like, if we have an index x and we know that the size of the elements is 9, that gives us our y, right? So, I mean, this is not it's a variable, but we know what the value is. So what we're saying is now we have y, and we want to find out what x is. Well, so let me rewrite this. What we're doing is we're saying x times 8 plus x is equal to y, right? And we're doing it this way because we can multiply by 8 really fast with the shifts. So what we're saying is this is x times 8 equals y minus x. And then we can divide by 8, but that does not help. So this does not work in the other way. This is essentially 8x plus x equals y, which, yeah, I know combines to 9x, but we don't want to do that. So assuming we know what y is, we don't know what x is. We want to take y and we want to subtract x and then divide it by 8. So let's say, whoa, that's cool. I didn't mean to do that, but if this is 81, for example, we have 8x equals 81 minus x. It doesn't really help because the problem is that in real math you just divide by 8 or 9 and things are fine. But because we're trying to do this in powers of 2, I'm at a loss here. So if we took 81 and shifted it 3 times to divide by 8, well, we saw what that does, right? That gives us 10 because it's an approximate. And we can confirm that with this guy here. So if we take 81, I don't know why this is not letting me type in now all of a sudden. Let's try again. Okay, Chrome, fine. Be uncooperative. Oh, you know what it is? It's that stupid stylus that I was drawing with triggering that behavior. Sorry. Load A, 81, and then LSR. So we get 10. So what we're trying to do is we're trying to find the index that would get us this multiplied by 9. Well, why isn't it the same as if we said, okay, our index is actually 9, so give us the... If we have our formula that we were using before, which is whatever the index is times 8 plus the index is equal to 81, right? If we're saying, well, actually, the index is... Oh. Hold on a second. Because that is... That whole times 8 plus 1 is... Or times 8 plus x is exactly just multiplying by 9. For... Right? We're saying it's... This shift is the first part of that multiplication, x times 8, and then plus x, which is obviously 9x. I don't know why I'm struggling with this here. So if we wanted to reverse the process, yeah, why doesn't that work? So we have 81 and we minus 9, and whatever this value is, we then divide by 8. We know it has to be a power of 8. And was I just making dumb mistakes and it wasn't working because of that? 18 minus 9. Well, no, because that still doesn't work. Unless it just doesn't work in that calculator for that. So 18, if we assemble and run that, gives us 2. I mean, and so for the value 9, it works. No, it doesn't. Why doesn't it? Wouldn't this be 0 left shifted left? Load A with 9. Clear. Oh, you dummy. Set the carry, please. Right. Okay, so now 18 is 12 in hex. It's like the index is off by 1. 45. 5 times 5, and then times 6 is 54, right? So is it just giving us our index off by 1? I mean, that's what it was doing, I thought, when it was just shifting. 54, 63. Is it good enough that we're getting just the number without the remainder? No, because in this case, the division Am I losing my mind here? We're getting 10, which is not the right answer. If we set carry and subtract 9, then we get the right answer, but that doesn't work for this. I think it's because right, it's because the thing we have to do here that we're not able to do is subtract by index value, right? Whatever that index value is. So in the case here, we know it's 4 intuitively because 9 times 4 is 36. So if I did a set carry and subtract 4, we'd get the answer is 9. The answer is 4 rather. But the problem is we don't know the answer is 4. Maybe let's see. How would we calculate that then? Why? I've never had to do this before. I'm surprised. So divide by 9. Let's say. Let's see if anybody else came up with. This is not helpful. Not 6502, the actual number. Well, divide by 7 is fine. So, well, I guess I don't feel so bad that I didn't figure it out based on the fact that there are all these answers here. What is this? Divide by 7 specific. That's not. But you know what? Could we take entity start and add entity counter and use that as our subtraction? I bet you we could, because if let's say, because that's the thing, right, is that we know where we're starting, we know where we're looking, so we should be able to just, well, actually, well, the only reason that I guess, I was going to say, well, actually, then do we even need to do this division? We could just take the entity start and add the entity counter The only thing is that if it's greater than the max entities, then we'd have to wrap it around. Is that any better or worse than... Like I was saying, the other thing we could do is we could take the X value... We take the entity start, the entity counter, we add them, then we subtract them from the value of X and then divide by 8. I feel like the other way is probably better. So what does that look like? So what that looks like is we say load a entity start, clear carry, I'd carry entity counter, compare to max entities. And so if we compared it to max entities and max entities was bigger, carry would be cleared. If it's smaller, then well, the other problem is that is it possible to have them wrap around? Yes, it is. So, okay, let's do it the other way because oh, well, no, because even though what is the value? 1C is 28. It's pretty small. It's pretty small, so it wouldn't... It's unlikely that the two would... Okay, so the entity counter could be 28, and entity start could be 28. That's the max, so that'd be 56, which wouldn't overflow. Okay, that's fine. So compare it. If max entities is bigger, then the carry will be clear. So branch F carry is clear. To here, and then otherwise we'll load. We'll set the carry and set the carry and subtract max entities. We just need to loop it back around and then store that into entity start and then just get rid of the rest of this garbage. That was oh. Oh, anonymous labels. Store it here anyway. Store it again. And then that. Okay. That was a little bit more than I'm sorry that was escaping me, but it was... Doing the math in the other direction is way simpler. And like I said, it occurred to me while I was kind of thinking this through. I'd never really thought to do the math in the other direction for any reason. And so it obviously doesn't work that way. If you don't know... If you don't know the thing you're looking... If you don't know the value of the thing that you're actually looking for, you can't do that division. In this case, because we know what our starting point is and we know how far we've counted, we should be able to just take advantage of that and not have to do the division. And mind you, we only did this for objects, so we have to do the same thing for projectiles, but we will do that in the next programming session because it's getting late, I'm getting tired, and I've already made a fool of myself enough when it comes to my inability to do simple division. Alright, so that has broken the things. Looks cool, but it's broken. Let's see what we broke here. So load a temp branch not equal. Not modifying X. Load A, the entity type for the object. If it's no entity, branch to there. Otherwise, let's say, let's give this an actual label. Done. Finding next start. How about that? And we'll call that. I know that doesn't solve the problem, but I just want to make sure that I have a name that looks a little bit more reasonable. Okay, so it looks like we're getting stuck in a loop, but basically what we're saying is, okay, increment the entity counter, load temp branch if not equal. So if it's 0, which it should be. Branch if not equal. First time through, it will be 0. So go to the next one, load A with the type based on X. We have not incremented X yet. We did. Okay, that's fine. That's all good. Compare the type. If it's no entity, then we're done, because we don't want to do anything with that. Otherwise, we're going to increment temp. We're going to load entity start. We're going to clear the carry and add entity counter, which the first time through, if there are no other objects, we'd have 0, and it should be 1. And then we store it into entity start, and then we compare it to max entities, and if the carry is clear, meaning max entities is bigger, then we would jump to done finding next start. Otherwise, we'd set the carry and subtract max entities and store that back into entity start, and then blah, that's the problem. Load a entity counter, or that's a problem. Hey, it's amazing what happens when you actually increment things the way they're supposed to be incremented. Let's, I didn't really get a chance to see what was going on with those sprites, so. It does not appear that they are changing order, though. Like, I am expecting to see... I'm expecting them to see... Oh, that is... Okay. That was along the lines of what I was expecting to see. Let's slow that down and make sure that that's actually... That's definitely better. I'd have to see I have to see what that actually looks like on a CRT to know if I've done it right. I mean, that's one thing with emulators. The flicker effect is not always, doesn't always produce the same kind of result as what you would see on the real thing. So that's what I want to check. For now, I'm going to consider that to be mostly success. Now we've got to change our couple of things. Let's make notes for next time, because as I mentioned, I will not be coding here on the stream on Thursday. So let's make some notes because I'm going to forget. So let's just do this in a separate window here. Entity projectile entities are not shifting for flicker. Need to add the entity start for projectiles to ensure that we get this. What else related to that? I'll test this out on some realish hardware coming up. I'll pop it into my EverDrive and give it a shot. Oh, you know what? That has to go away. We were still incrementing the entity start. That was looking more like what I was expecting, but it was in sort of the background, so it was hard to see. All right, I thought it looked like it was doing what I wanted. But yeah, that's what it should be doing. It's cycling through. Oh, how did I miss? Yeah, so it's cycling through now. Oh, it's even doing it for the... You just can't see. Oh, okay, so that's why it's not running at a speed that's slow enough that you can see that alternating. But that's what it's supposed to do. And then it should do the same thing with the projectiles. And you can see the ship is shifting its spot around. And that should help. All of that shifting around that's happening should help ensure that we get sort of consistent coverage across the sprites, so that, or the objects, so that the sprites that are drawn reflect at least some of the entities in a sort of consistent way to give that flicker effect. So we'll see. We'll like I said, I'll test that on some real hardware and see what that actually looks like on a CRT. And if it looks good, then I'll be satisfied with it. If not, we can always revisit it. But as always, thank you for watching. If you want to reach out to me, I'm on Twitter at Clearvis. I'm on Nintendo Age as Zelius. You can email at zelius@gmail.com. Thursday we'll be talking, like I said, to Jonathan at Oleschool Gamers. I'll link his channel below. Definitely check it out. And hope you guys will attend the live stream on Thursday at 9 p.m. Eastern. Until then, have a great rest of your week, and I'll talk to you later. Thanks for watching. Bye.